Alright, let's look at the homework 1.5-1.6, problem number 6. Alright, so let's find the domains of the following functions. Alright, so let's look at part A. Alright, so we have a fraction form, so we have to make sure that the denominator is non-zero. So this guy cannot be equal to 0. Alright. So maybe I'll add e to the 9 minus x squared to both sides. Then that way 1 is not equal to, right? So that cancel out. Then you have e to the 9 minus x squared. Right? So e to the what power becomes 1, right? So the power we need to make e to the some power is equal to 1 is that this power has to be equal to 1. So because e to the 0 would be 1. So we don't want 9 minus x squared. We don't want this guy to be 0, right? Otherwise e to the 0 is going to give you 1. Alright, then this is just a quadratic inequality, so we can just solve that and add x squared to both sides. So you have a 9 is not equal to x squared. Right? Then we can just take the square root of both sides. So square root of 9 is 3, right? But and the square root of x squared would be x. But we have to consider plus or minus. Right? Every time you take the square root of an equation or inequality, you have to consider the positive one and the negative one. Right? So it looks like we have to take all real numbers except for positive 3 and negative 3. Right? So interval notation would be, let's see, interval notation would be, that's a small box, negative infinity all the way to negative 3, then skip negative 3, go to positive 3, and skip positive 3, then go to infinity. Right? So let's type that guy in first. Right? Alright, so you have a negative infinity, right, to negative 3. Right, then skip negative 3 and go to positive 3 and skip positive 3 and then go all the way to positive infinity. Alright, so that's that. Alright, and let's look at the part B. Alright, so same deal, we have a fraction, so we have to make sure that e to the cosine of x, so denominator, is not equal to 0. Right, but remember that the exponential function e to the any power is actually always positive, so it's never 0. So no matter what cosine value you're going to have, you're going to actually have a positive value there. So automatically it is not going to be 0. Alright, so we can plug in any number you want, which means that the domain would be all real numbers. Alright, so let's type it in. Alright, so it's going to be a negative infinity to positive infinity. Alright, so that's that. So let's double check, submit for testing. Alright, it came back and looks like we got both of these guys correctly. Alright, that's it. I hope that this was clear.